Picture a man in a village, 10,000 years ago, sitting by a fire feeling completely fine. 6 weeks ago, a dog bit him on the hand. The wound closed. It healed cleanly. He barely thinks about it anymore. But something is moving inside him right now, as he sits there. Something microscopic, traveling slowly up the nerves of his arm at roughly the speed of a fingernail growing, heading toward his brain. He has at most a few weeks left. There is nothing anyone in his world can do. There is nothing anyone in our world could do either, if it reached this stage. And the truly unsettling part is that he feels completely normal. This is rabies, and to answer the question this video is named after, we have to start with something uncomfortable. Ancient humans did not survive rabies, not in any meaningful individual sense. Once the virus reaches the brain and symptoms appear, rabies is very close to 100% fatal. And it has been that way for every single year of human existence. Not 90%, not 95%. Effectively all of them. There is no other infectious disease on Earth that comes close to that. Ebola kills roughly half. Untreated bubonic plague kills perhaps 6 in 10, smallpox killed around 3 in 10, rabies kills essentially everyone it symptomatically infects, and it has never stopped doing so. Think about how unusual that is. Nearly every disease humans have ever faced leaves survivors. Some people recover, some people are naturally resistant, some populations over generations develop partial immunity, and the disease slowly becomes something people live through rather than die from. Rabies has never done any of that. In roughly 4,000 years of written records across every civilization that documented it, the outcome has been effectively unchanged. So the real question is not how individuals survived it. Almost none did. The real question is far more interesting. How did our species survive something with a perfect kill rate for tens of thousands of years, with no medicine, no understanding of viruses, and no vaccine until 1885? The answer involves a strange quirk of the virus itself. A few pieces of genuinely effective ancient medicine that worked entirely by accident, and a great deal of hard-earned cultural knowledge purchased at a price we can barely imagine. If you find these kinds of stories fascinating, the ones where the honest answer is stranger than the popular one, take a second to subscribe to the channel, so the next one finds you. Now, let's look at what is actually happening inside that man's body. To understand why rabies was, and still is, so uniquely unstoppable, you have to understand what makes it different from almost every other pathogen humans face. Most viruses want to spread through your bloodstream. They multiply fast, they flood your system, and your immune system notices immediately and responds. That response is what a fever is. That response is why you feel sick. Rabies does almost the opposite. After a bite, the virus does not rush into the blood. Instead, it quietly enters the nerve endings at the wound site and begins traveling up the peripheral nervous system toward the spinal cord and brain. It moves slowly. Researchers estimate a rate of roughly a few millimeters to a few centimeters per day, which is why incubation typically takes weeks, sometimes months, and in rare documented cases, years. That timing is not random. A bite on the face reaches the brain far faster than a bite on the foot, and incubation shortens accordingly. A pattern doctors have observed consistently, but here's the genuinely diabolical part, and the reason this virus is so nearly unbeatable. The nervous system is what immunologists call immune privileged. Your immune system polices it far less aggressively than the rest of your body, for a very good reason. Inflammation inside a brain is catastrophic. Swelling in a confined skull kills. So evolution built the nervous system to be left largely alone. Rabies exploits that perfectly. By traveling entirely inside nerve cells, it stays almost invisible. There is essentially no immune response because the immune system barely registers that anything is happening. The man by the fire has no fever because his body does not know it is infected. By the time the virus reaches the brain and begins replicating explosively, the immune system finally notices, but now it is too late, catastrophically late, because the infection is already inside the organ it cannot save. And then the symptoms begin, and they are among the most disturbing in all of medicine because they are not random damage. They look like manipulation. The virus produces intense agitation, confusion, and aggression. It concentrates heavily in the salivary glands, causing dramatic drooling, loading the saliva with infectious particles. And it causes hydrophobia, the famous fear of water, which is not really a fear at all. It is a violent involuntary spasm of the throat muscles triggered by any attempt to swallow, so painful and terrifying that patients recoil from water entirely. Think about what that combination accomplishes from the virus's perspective: saliva loaded with virus, a throat that cannot swallow it away, and an overwhelming urge toward aggression and biting. The virus has, in effect, turned its host into a delivery system, and there are very few examples of behavioral manipulation this precise anywhere in nature. So how, then, did our species get through this? The first answer is the most important one, and it is a genuine quirk of biology. Humans are a dead end. Rabies is superbly adapted to spread between animals that bite each other routinely. Dogs, bats, foxes, raccoons. Humans do not do this. An infected human in the throes of rabies almost never manages to transmit it to another human. Documented human-to-human transmission is vanishingly rare outside of organ transplantation. This matters enormously. It means rabies could never become a plague. It could never sweep a village or a city or a continent. Every single human infection was, epidemiologically, a dead-end road. A disease that kills everyone it touches, but cannot spread between its victims, is a tragedy for individuals and families. It is not a threat to a species. That is the fundamental reason we are still here. Not resistance, not treatment, just a mismatch between the virus's strategy and our behavior. But that only explains why rabies never wiped us out. It does not explain what people actually did about it, and the historical record here is remarkable. Rabies appears in some of the oldest written documents humanity possesses. The Codex of Eshnunna, a Mesopotamian legal text dating to roughly 1930 BC, contains a striking provision. If a dog is known to be aggressive and dangerous, and the owner fails to restrain it, and it bites a man and that man dies, the owner must pay a substantial fine in silver. Read that again and notice what it implies. Nearly 4,000 years ago, someone understood that certain dogs behaved abnormally, that their bites caused death, that the death came later rather than immediately, and that the owner should have known. That is a working, functional understanding of rabies transmission, written into law thousands of years before anyone knew what a virus was. Aristotle described the disease in dogs in the 4th century BC, noting its madness and its spread through bites, though he made one significant error, claiming humans could not catch it, which was tragically wrong. By the 1st century AD, the Roman writer Celsus got considerably closer to the truth. He identified saliva as the vehicle of transmission, described hydrophobia in detail, and recommended a specific treatment: cauterization, burning the wound. And here is the thing that makes this genuinely fascinating, that actually worked sometimes, not because anyone understood why, but because the rabies virus in those first hours and days is still sitting at the wound site, waiting to enter the nerves. Destroying that tissue, brutally and completely before the virus migrates, can genuinely prevent infection. It was agonizing. It was performed with red-hot iron on conscious patients, and it was in principle sound medicine arrived at by pure observation, roughly 1,800 years before anyone knew what they were killing. This same logic explains a strange medieval practice. Pilgrims traveled to a shrine in France to be treated with the key of St. Hubert, a metal object heated in a fire and pressed to a bite wound accompanied by prayer. The prayer did nothing. The red-hot metal applied early, sometimes did. Modern medicine, incidentally, has kept the underlying principle while dropping the brutality. Thorough washing of a bite wound with soap and water is now understood to meaningfully reduce infection risk by physically removing virus before it enters the nerves. Ancient wound washing, practiced across many cultures, likely saved lives nobody ever counted. But for every practice that worked, there were dozens that did not, and the historical record is full of them. Pliny the Elder recommended eating the liver of the dog that delivered the bite. Others prescribed ashes, herbs, charms, and countless variations. American folk medicine had madstones, hardened masses taken from deer stomachs, pressed to wounds to draw out the poison. Every one of these was useless, and in a disease with an incubation period of weeks, they generated a devastating illusion. Most animals that bite people are not rabid, so most bite victims survive regardless of what is done to them, which meant every one of these worthless treatments appeared to work, most of the time generating unshakable confidence in remedies that did absolutely nothing. The most effective ancient response was not medical at all. It was behavioral. Communities across the ancient world learned to recognize the signs: an animal staggering, drooling, unafraid of humans, attacking without provocation, and to kill it on sight, at a distance, without hesitation. Roman writers described the culling of dogs during outbreaks. Similar practices appear across many cultures. There is a bitter irony here worth noting. Dog domestication, one of the great achievements of the human story, is also very likely what made rabies a serious human problem in the first place. Wild wolves rarely encountered people. Village dogs lived among children. We brought the amplifier inside the walls ourselves, and the knowledge that came from that arrangement was purchased in the worst possible currency. Every rule about which animals to avoid, every recognition of what a rabid dog looks like, every instinct to keep children away from a staggering stray, exists because somebody at some point learned it the other way and did not survive the lesson. That kind of knowledge does not appear in any archaeological record. It leaves no tools, no bones, no artifacts. It survives only as culture, passed from adult to child, generation after generation, in villages that had buried enough people to be certain. The wait, though, may have been the worst part, because after a bite from a suspicious animal, there was nothing to do but count the weeks. Some people, historical accounts record, killed themselves rather than wait, or begged to be killed once symptoms appeared, and families sometimes complied, because everyone knew exactly what was coming. That was the state of things for roughly 10,000 years. Until 1885, when a 9-year-old boy named Joseph Meister was brought to Louis Pasteur, having been bitten 14 times by a rabid dog. Pasteur had been working on an attenuated rabies preparation, but had never used it on a human. He was not a physician. He faced prosecution if it failed. He administered it anyway, over a series of injections, racing the virus up the boy's nerves. Joseph Meister lived, and the long, unbroken certainty of rabies finally cracked for the first time in human history. What made Pasteur's approach work is the same thing that makes rabies so terrifying. Turned around and used against it, the virus travels slowly. That long, silent incubation, the very feature that makes rabies so cruel, also leaves a window, weeks long, in which the immune system can be taught to recognize the virus before it ever reaches the brain. Rabies is, in that sense, almost unique. It is the only common disease where a vaccine given after exposure still works because the pathogen is simply too slow to outrun a warned immune system. Modern post-exposure treatment descends directly from that gamble, and it is remarkably effective. Administered promptly after exposure, it prevents rabies almost without fail. Which brings us to the modern twist, and the most unsettling detail of all. In 2012, researchers testing people in remote Amazonian communities in Peru, in regions with heavy vampire bat exposure, found something unexpected. A meaningful percentage of tested individuals carried rabies-neutralizing antibodies despite never having been vaccinated and despite being alive. Interpretations remain debated, and the finding is genuinely difficult to explain, but it raises a possibility that would have been dismissed outright a generation ago, that some exposures may be survivable without ever becoming symptomatic. If true, it would mean the picture is slightly less absolute than we thought, slightly, but do not misread that. Once symptoms begin, rabies remains what it has always been. There have been a small number of documented survivors of symptomatic rabies, most famously through an experimental approach called the Milwaukee Protocol. Nearly every subsequent attempt to reproduce it has failed, and most experts today regard it as unproven at best. Symptomatic rabies remains, for practical purposes, the most lethal infectious disease known to medicine. And here is the ending nobody expects. This is not a historical story. Rabies still kills roughly 59,000 people every year, almost all from dog bites, almost all in places where the vaccine is unavailable or unaffordable, and a large share of the dead are children. We have had the answer since 1885. It works nearly perfectly. It simply does not reach everyone. So somewhere tonight, a child is sitting by a fire, feeling completely fine, weeks after a bite that is already healed. The virus in that child's arm is doing exactly what it did 10,000 years ago, at exactly the same speed, with exactly the same outcome. The only difference now is that it no longer has to end this way.